Okay guys, you might remember this from one of my previous videos. It's to scale the model of the bridge using the drawings. And so what I did now is I grabbed two pieces of steel. The width of the bridge is the same, so that's the width. These are dimensionally different. The one is it's a few inches larger than the other in width, but we're not going to even concern myself with that because I'm stating it's not going to be any sliding going on. That you can't slide that once you put a load here, because they have the load of this sliding coming from here pushing out the clamp force between this one and that one, and they have none of them are talking about this joint failure. So I'm going to weld this together. We're going to apply a load on it, and yeah, I'll let it go wild a little longer. Saves me from ruining this piece of metal by cutting it to the width. I'm going to do another video, but this will not buckle with the weight we're going to put on it. I'm going to show you that it's just not going to slide. That this joint, as long as it's intact, which all evidence shows that it was intact, nobody's stating otherwise either, that this, the end of that, can't move out as long as this joint is intact. Now, let me say something that's really triggering me all the time here, is that the bottom 11 is all cracked up. How come all these engineers, these professional engineers and expert forensic people and everything else, can avoid the damage that's inside number 11 at the bottom? They can talk about it, point at it, tell you about it, and that's it. But they don't. With that split in number 11 on the other side, how come they don't talk about the load being applied to there with that split being there, that it would buckle? At that point, it would buckle. How come they're not talking about buckling? Man, it triggers me so bad. That if this load was coming down here, it wouldn't have the ability to push that off. Those cracks, they're in that number 11 that I show in the other part of, I guess I'll might make it a thumbnail and add it in a picture. But where they put the tape measure down it and all, down number 11, that those loads would buckle that number 11. And how come they don't talk about how those cracks presented themselves, the way he's putting a tape measure down it? How come they don't talk about that? Because it doesn't fit their narrative, their lobbied narrative. Okay, let's go ahead. Let me weld this up and get you guys this video. I'm going to just load this up for you so you can see what I'm up to. Again, then I'll weld this joint. Then we'll put the loads up top, weights. We're going to lay it down on something something that will allow for sliding very easily. In fact, we might not even cut the end flat. That would give me too much surface area. And we might just leave it like that, where it's got a little bit of surface area. So it will have a more of a chance to slide outwards. I think that would be even more proof of concept, because then it's got less, it'll have more ability to slide. If I cut it like that, I'll also have to put a flat piece on it, and of that dimensions, to watch it slide or not. That would give me more friction, incidentally, if I cut this and then put a plate from here. Well, it would be right about that line there to there. So it would be like that with a flat plate. But I don't need that flat plate. I think we'll do that. All right, just wanted to, and over here will be the same. Except for this, you're going to not see this thing kick out. It's going to be weld. It's not going to move out with the weight I'm going to put on it. I'll put, I don't know, a 35-pound weight on it. This won't buckle. If it does, I'll have to cut it short. I'll put it to scale. But the buckling is what we would see. For it to kick out, it's only kicking out in their theoretical model. It kicks out one direction, but not this direction. Yet they're clearly stating the load is down here, but it just goes that way for one reason only. It doesn't go back that direction also, but per their model. But they also don't show the brakes. They don't talk about the brakes in the canopy, nor the deck so far have I found it. I mean, I could be wrong. I could keep looking. But they just, look over here, look over here. This is that magic BS shit I tell you about. I call it robbing a bank. You know, you go and rob a bank. You look like a regular customer. You hand them the note, right? In reality, you're smiling. It's smoke and mirrors. In reality, you're robbing a bank. They're robbing a bank right now, telling us that. There's got this huge crack here that should buckle. That all engineers say, well, that huge crack should result in buckling. But you even got these guys from Europe and everything else commenting on this structure, but everybody's scared. These engineers are scared to speak up. I mean, they don't have any balls, put it that way. Bye.